Hey, this is Mr. Aiden from MrAiden.com, and we're going to be going through the 2021 AP Calculus AB exam. We're going to be going through free response question number 1. So let's get to this question. It's a calculator problem. Of course, number 1 and number 2 are calculator problems. And number 1, you can see we're given this table. We're given this table of how the density of bacteria population in a circular petri dish at a distance r centimeters from the center of the dish is given by an increasing differentiable function. So right away, two things you want to note is that it is an increasing function. It is differentiable, which means many things apply. You can see f of r is measured in milligrams per square centimeter, and these values are given in the table above. And the first thing we're supposed to do is to estimate f prime of 2.25. So you can see f prime of 2.25 is right in the middle of these two values, right in the middle of 2 and 2.5. And you know when we hit f prime, we're taking a look at the derivative, and so the derivative is the slope between these 2 points. So f prime of 2.25, we're going to be taking a look at this y2 value of fr, and that is 10, that's milligrams per square centimeter, minus 6 milligrams per square centimeter, and this is all over 2.5 centimeters, minus 2 centimeters. And so we're going to do kind of the average value between these 2 points. And we end up getting 8 milligrams per centimeter cubed. And you can see how the units really help you out to be able to interpret the meaning of the context of this problem. And so what do we see is the density of the bacteria is increasing. This is positive. It's increasing at approximately 8 milligrams per centimeter cubed at 2.25 centimeters from the center of the dish. So that is our meaning of this answer is our density of bacteria population is increasing at a rate with respect to the amount of centimeters at 8 milligrams per centimeter cubed at approximately 2.25 centimeters away from the center of this dish. Okay, and so that's how you would kind of write this interpretation of this meaning here. And then we go on to part B. Part B is asking you for, we have a value here. We have the integral from 0 to 4 of r times f of r dr times 2 pi at the end. And we're using a Wright-Riemann sum. And so we need to use a Wright-Riemann sum in order to do this. And so when we have 2 pi, the integral from 0 to 4 r times f of r dr, we're doing 2 pi times the Wright-Riemann sum. And so remember the Wright-Riemann sum is we have 18. 18. And we'll start with the right-hand side. We have 18. So we have 18 times this difference in the x, the delta x, which is 1.5. But we have to multiply that by the r at that exact point, and the r is times 4. So we're going to do that r times the integral of f of r for each and every point. Okay, then we go to the second point, which is 10 times delta x. The delta x goes from 2.5 to 2, which is 0.5 difference. And this 0.5 difference, again, we're multiplying by the r, which is 2.5. Okay, 2.5. Plus, we go to the next point, which is 6 times the difference between 1 and 2. That's the difference of 1. And times the r, which is 2. Plus, the next point is 2 times the difference between 1 and 0. That's 1 difference. And our r is equal to 1. And so we do all of this, and we end up getting, we multiply all of these things. We multiply by 2, and we carry the pi, and we end up getting, I got 269 pi. 269 pi. And let's take a look at the units of this. This 18 is 18, and I'm going to do this down here if that's okay. 18 milligrams per square centimeter. I multiply it by this delta x, which was a difference of 1.5 centimeters, times r, which was 4 centimeters. So you can see this centimeters and this centimeters cancels out with the centimeters squared, which means this is in units of milligrams. It's 269 pi milligrams. Okay. The next question, question C, we want to know whether this is a overestimate or underestimate. Well, remember we said that one of the important things is it's an increasing function. Okay, so this function is going to, if I kind of just sketch it out real quick, it is an increasing function, which means if we're taking a right Riemann sum, we're taking this right point times your delta x, 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 and you can see an increasing function, an increasing differentiable function, and a right Riemann sum is always going to be an overestimate. And that's your justification. Your explanation is you can kind of draw a little picture here. You can kind of sketch out your graph. You can also say that a right Riemann sum will always be an overestimate if the function is increasing and differentiable, of course. Okay. And then the last part, part D. Part D, we're given a new function, g of r. g of r equals 2 minus 16 cosine 1.57 square root of r to the third power. And we're trying to look at when between 1 and 4 is g of k equal to the average value of g of r. And so we want to find the average value. We have to understand, remember how to do the average value. And how do we do the average value? We have 1 over, we have b minus a, that's 4 minus 1. So it's going to be 1/3 of the integral from a to b, 1 to 4, of g of r dr. And if you do this on your calculator, you end up, you want to define this g of r in your calculator. You can define it as f of x or g of x, however you want. You're going to do this integral, this average integral, and you end up getting 9.8757. And I'm going to round the 9 right there. And so this is what we call our average value. Now we want to find out where that average value is equal to your true value. And so on my calculator, I solved and I did g of r equal to my 9.87579, and I'm solving for r right there. And you end up getting a value when this equals, k is equal to 2.497. You could also graph it out as well. Let me show you if I graphed it out. You can see on this graph, I graphed out this function 2 minus 16 cosine 1.57 square root of x cubed. And I took a look at this value right here, and you can see where does it equal this 9.875. If you kind of zoom in a little bit, 9.875, we're almost there. We're really close. It's between these 2 points. You can see right around 2.5. You can zoom in, zoom in, zoom in. You can use your calculator to take a look at that if you want. And our k is 2.497, which is between 1 and 4, and that's where the instantaneous value, okay, sorry, not that instant, that value of this whatever k value would be equal to the average. And that is question number 1 for Free Response 2021 AP Calculus AB. Hope that helped. Catch you on the flip side.